We're going to take a look at graphing a linear inequality. That's an inequality involving two variables, generally x and y, and an inequality symbol like greater than or less than, greater than or equal to, less than or equal to. It's going to kind of combine two things that we already know together, so I want to recap what those are about. The first thing I want to look at is graphing an inequality of only one variable. So let's say we were trying to graph the inequality x is greater than or equal to 5. That is a one variable statement, so we would be able to plot this and show it graphically in a one-dimensional way on a number line. So to show this, we need to have a number line that's scaled, making sure that 5 is on there somewhere, and we want to graphically show all of the numbers that make this statement true. Well, what numbers are those? Well, 5 would make it true because 5 is greater than or equal to 5. 6 would make it true because it's greater than or equal to 5. 7, 8, 9, all those numbers would make it true, but nothing to the left of 5. So we would graph this by plotting the boundary first, which is 5, deciding whether that should be open or closed. Because this statement says that x is greater than or equal to 5, that means it can equal 5, and a shaded filled-in number shows that it can equal 5. Now we're going to shade one way or the other, and the direction where the x values are bigger than 5 are all of the numbers to the right, so we need to shade this to the right. And that would graphically show all of the numbers that are greater than or equal to 5. Greater than are shaded here, the equal to is shaded here at the boundary, and that's our graph. Now the second idea that we already know about, that this is going to connect to, is graphing an equation in two variables. So for example, y is equal to 2x, let's use a fraction here. Y is equal to 3 over 2x minus 6. If we were going to graph that equation, we would want to show a line that shows all of the x, y pairs, all of the ordered pairs, that make that statement true. So we would start at the y-intercept, which is 0, negative 6. That point would make it true. And the slope is 3 over 2. So remember that the slope is the change in y over the change in x. So the change in y is 3, the change in x is 2. So whenever x increases by 2, y increases by 3. Right 2, up 3. Right 2, up 3. Right 2, up 3. And we have all these points. And so we would graph that with a line. Now what this line does is show all of the ordered pairs x, y that make this statement true. Choose any x, y that we have. Like here's the point 6, 3. Substitute that in, and it makes that equation true. If we change this up, and instead of looking at this in terms of an equal sign, let's say that was a greater than or equal to sign. Well, we've already graphed the line showing where y is equal to 3 over 2x minus 6. And now we need to throw in all the points that are also greater than. When we're doing this with one variable, we graph to the left or the right because it was a number line that went left and right. Now y, that is all the values up or down. So we want to show all of the y values that are greater than or equal to, or that are above this line. And those are going to be all of the points that are above the line. So don't think about this in terms of left and right. It's y. So think about this in terms of up or down. And all the points that are above the line, that is where we have shaded values. So if you pick a point that is within a shaded region, like let's say, I don't know, negative 2, 4. That is a point that is within the shaded region, negative 2, positive 4. If we substitute that value in, it should make this statement true. So y is 4 is greater than or equal to 3 halves of negative 2 minus 6. Well, 4 is greater than or equal to 3 halves of negative 2 is going to be negative 3, because that's negative 6 divided by 2, minus 6. So 4 is greater than or equal to negative 9. And yeah, that is absolutely true. So we took a point in the shaded region. It was true. if we take a point that's outside the shaded region, like here's the point 10, 0, that being outside the shaded region should make it false. So y is 0, greater than or equal to 3 halves of 10 minus 6. So we have 0 on the left, greater than or equal to 3 halves of 10. Well, 3 times 10 is 30, divided by 2 is 15. And 15 minus 6 is 9, and 0 is definitely not greater than 9. So this statement that we have is false, which makes sense because we got it from the unshaded region. Let's take a look at one more example and kind of just go through this process one more time. Let's say we have y is less than negative 2x plus 7. If you're graphing a linear inequality like this, you're going to start by graphing it almost the same as you would graph a line. So we would start up at positive 7 as our y-intercept, and the slope is negative 2, so increase x by 1, decrease y by 2. So plot all these points, but don't graph the line, don't sketch the line yet, don't connect them, because you need to make a decision. Just like before, you had to decide whether you had an open circle or a closed circle at the boundary. We need to do that here. So we have this line is going to be the boundary, and we have strictly less than. So if it was like one variable, you would have an open circle. We need to have basically an open line, and that is going to be graphed as a dotted line. So whenever you have a strictly greater than, you're going to draw a dotted line. What that dotted line signifies is that a point on the line is not a solution. Now we need to shade one direction or the other, and this is saying that y is less than negative 2x plus 7. So less than, what direction is y when it's getting less than? Well, y goes up or down, and when y goes down, it decreases. So all of the y values that are underneath the line, those are the y values that are less than. If you want to make sure that this is correct, grab a point in that shaded region and make sure it worked. So here is the origin, probably the easiest one to check. So 0, 0 is in the shaded region. It should make it work. So 0 is y is less than negative 2 times x is 0 plus 7. So 0 is less than 7. Yep, that is completely true. So this indicates that we've shaded the right direction.